screen there. Right, realising the potential of longitudinal diamond grinding, LDG, and next generation concrete surfacing, which is a new treatment as far as the UK is concerned. So kind of split into three parts, a bit on the background, a section on the LDG in terms of its introduction to UK historic sites and performance of those sites, and then the final bit on next generation concrete surfacing, the research and the background, and also development of the trial scope and the specifications for it, and then obviously getting it done, and some initial monitoring of performance as well. So, background. I'm not going to go too much into this because this graphic came up in one of this morning's presentations. The only thing I'll add is it's around the exposed concrete is around about 4% of the strategic road network, mainly jointed concrete, either unreinforced or reinforced, and there's some sections of CRCP in there as well, and primarily used to reinstate the surface characteristics that we want, either in terms of skid resistance and texture, and also to reduce the noise levels as well. So there's quite a wide range of other techniques that have been used, shot blasting, fine milling, and then the two that I'm going to focus on here. So LDG, as I've said, it's there to restore surface characteristics to make sure that the road is maintained in a safe condition, but it's also very good at reducing levels of noise. It consists of closely spaced diamond blades to remove and retexture the surface. Typically, the grinding head consists of around about 250 diamond blades on a 1.2 metre wide cutting head. Quite widespread UK experience going back 13 years, so the first sites being on the A12 and the Chelmsford bypass, and another further sites at Kelvedon, and another site on the A14. Those are all quite historic, 12, 13 years old. And then more recently, it was included in a trial on the M1 between junction 6 and 5 southbound. So basically, you've got a positive texture created using the blades. You've got a grind width of 2 to 4 mil, and a land width of between 1.75 and 3.25, and you've got a grinding depth of approximately 3 mil. So benefits. You could do the works in off-peak hours with short mobile lane closures, because once you've run a process along the site, you can then get off the site and you can traffic it straight away. There's no curing time. You just need to clean up any debris that's caused by the cutting process. It will also remove any unevenness between the joints and improve the ride quality. I kind of sort of think from what I've seen of concrete pavements, I think it's not just that. I think it makes the overall surface more even between the joints as well. I'll come back to that when we talk about next generation. And it obviously restores the surface characteristics for skid resistance and noise. So we need to think about the safety aspect. No remedial works to drains, barriers, bridges. And this doesn't damage joints, and that's not true for all of the surface treatments. So M1 installation, this is more recent. So this is 2018. So it's just a picture of the installation, the grinding head, and also the installed surface. So I don't suppose anybody at the back is not going to be able to see anything on here, but basically this is showing the skid resistance performance over time. So we've got an average scrim, and the only thing that the only site where it's actually dipped quite markedly is the more recent site on the M1. So there's some debate over have we got a different aggregate on the M1 that's causing that. But basically it's showing satisfactory skid resistance for over a prolonged period of time. So it's only when we get to 7, 8 years till we get down towards the investigatory levels for a non-event carriageway. High-speed friction. Again, the shaded bands on here is what we would call normal for this type of these type of materials. So this is some data from TRL report, because they did a lot of the monitoring on the early sites on the A12 and A14. Initially, they suggested it takes approximately 36 months for the peak friction values to return to original levels, but that's been updated really. So it's now talking about 6 to 7 years, and that was updated in 2017. Again, we've got this issue. The red dots at the bottom there is the M1 6 to 5 site. So noise performance. So the previous studies on the A12 and the A14, you've got values of close proximity testing there of sort of around about 98 decibels immediately after treatment. And then we got values of around about 99 to 101, with about 6.5 years later. So on the M1, we ended up with 96.5 after installation. And that was about 5 decibels lower than the non-treated control area. And so far it's been maintained below 99. So, and the graphic on the side there, that's comparable with the standard thin surface core system after 3 years in service. The super low one there is an ultra thin surface course, which is only a 6 mil aggregate, so that's substantially below again. But if you look at the 2 lines at the top, the green one is the shot blasting, and that didn't really make any difference in terms of noise reduction. And this is a graphic on the tracks data in terms of the ride quality, and basically the dots higher up are pre-treatment. And then you'll see there's a much more consistent in terms of ride quality after treatment. So we're kind of talking 60% improvement in 3 metre data and 64 in the 10 metre data. So specification and conclusions from the LDG. UK trials, they basically demonstrated a positive reduction in noise generated at the road tyre interface, significantly improved skid resistance, texture and ride quality. And then there was the LDG SHW clause published in 1092, or that be part of the CC 203 we heard this morning? 204. That's all right, okay. And basically the spec provides the standard requirements for the preparation, equipment, grind spacings and performance requirements. So key design considerations for all concrete treatments are level of traffic, what the aggregate type is. I think we need to do a bit more on that in this area. Type of PQ construction, what's the residual life of the pavement, what's the existing noise level, and what is the surface life required. If it's going to be replaced in 5 years, then it's just a short life extension works, interventions needed. So moving on to next generation concrete surfacing. It's kind of a variation on the LDG, to be honest. So it's an innovative surface treatment to further reduce noise and enhance the skid resistance. So it was being used in the States for quite an extensive period of time. So we got the Federal Highway Works Administration, the International Grinding and Grooving Association, and the American Concrete Paving Association, and I think it's the Minnesota Department of Transportation. So that research identified the refinements to the grinding and grooving dimensions, significantly improved noise performance, texture and durability compared to the LDG. So it's been used extensively in many US states and also other parts of the world, South Korea, Australia, parts of Europe. So Belgium and Germany are using this quite extensively now, and that was also in Anne's presentation this morning. And that amounts to about 4 million square metres. That figure's probably quite a few years out of date now, so I expect it's significantly more than that. So it's a hybrid texture that combines techniques of diamond grinding and longitudinal grinding. So creating a uniform land profile, so essentially all negative texture, and typically it's a two-stage process involving two machines. So you've got a flush grind, and then a second part of the operation is to do the longitudinal grooving. If you have a really rough surface with lots of stepping and a super rough concrete surface, then you would need an additional bump grind as well to improve the profile before you do the flush grind. But we didn't think we needed to do that because I think the M1 was looked at in daylight conditions and it looked super smooth in the daylight. When you look at it at nighttime conditions, it's not so super smooth. So, and there's this little graphic of what you kind of end up with. So the actual land, the top area is between 12 and 16 millimetres wide. And then you've got the deeper grooves, which are basically between 3 and 5 millimetres deep. So international engagement. There was a working group created in June of 2020, a couple of years ago, reviewing the technology readiness levels and the potential for application in the UK. So, and there's the work we're doing is for Connect Plus. So we've been working closely with Connect Plus Services, Milestone Infrastructure, that used to be Skanska, and obviously Road Grip, the installer and the blade supplier. So we had lots of consultations and meetings together before we got to the stage of moving it onto site. So we kind of went for the US approach because that was where there was the longest experience. And it's they tend to primarily use it to reduce noise, and it's carried out in more noise-sensitive areas. But also looking at the data, it seemed to be more durable in delivering the properties we wanted. The IGGA spec does allow you to use it in a single pass, but talking to colleagues in America, they said that's not a very good idea. You should do it as a two-pass process, otherwise you get differential wear in the blades, and then you might actually have to stop and reset the whole cutting head. So it's kind of important to set it up as a train. So you do one part and do the grooves before you then get off and then reopen it again. Or you can traffic just the flush grind for a short period of time without any skid resistance issues. And the original trial on the I-94 in the States is still in place. So that had quite strong evidence of its potential durability. And also the European experience. I think we had a bit on this this morning in terms of the variation in the actual flush grinding head in terms of the spacing between the blades that we use. And I think there's some more work to be done, and also the spacing between the deeper grooves as well. I'm basically saying that it's got lower rolling resistance, noise level decrease has the potential of reducing the noise by about 6 decibels. So that was from the European experience. So there's Germany, Austria have done quite an extensive amount of work on the grooving and grinding blade dimensions, and that was developed independently from the US. So I think there's a lot we can learn from Europe. And there's been quite a lot of research projects published in the last 10 years as well. And then there's a German report from a site reported back in 2016. and the bit down the bottom there is just showing the variation that you could get in terms of what sort of land area do you want. To me, intuitively, I kind of sort of think the wider that land area is, the more robust it is, you're less likely to get pieces of aggregate plucking out. But then you've got to optimise it and see what sort of performance do we need to have in terms of noise reduction and durability of skid resistance. So the specification clause that we used was basically based on the US system. So we basically followed that, converted it all into metric. I debate the 92 to 100 blades per 0.3 meters because the mass doesn't stack up, but that's what's in the specification. So that's basically a comparison between the two types, the LDG single pass and the next generation two passes in terms of what it looks like. And there's just a little graphic of the two profiles down the bottom. So this is basically all those involved in the process. It's basically taken us through that program from the original literature review, discussing it internationally. This time last year, we were at the point of telling everybody we're just about to do this. And this was did the detailed design, the spec, and the mobilisation construction was carried out in November and December of last year. So now we're into the monitoring phase. So the site is located again on the M1, so we've got similar traffic conditions to the existing M1 trial site. That was installed back end of last year, beginning of this, and it's the first UK installation of this on the strategic road network, and it was approved via a departure from standard. It's basically led by Connect Plus Services in collaboration with National Highways, and then the delivery team is Atkins, Milestone, Road Grip, and Tyrrellet as well. And the trial length was 550 metres long across all three lanes. So there was all sorts of fun in terms of getting the logistic right of the train set up, and we had a different grooving head width to the flush grind head width. So there's all sorts of fun and games going in different directions because they didn't take the rumble strips out either, and keeping all the equipment level to get that done. So the aim is to maximise durability, skid resistance, both initially and throughout its service life. And also we can evaluate the performance of this relative to the LDG, which is just a bit further down on the M1. And we've also taken a look at the whole life cost analysis and the carbon footprint during the construction phase. So this is the trial installation. So we started off with a small section of the hard shoulder just to get the kit up and running. That threw me. I didn't know there was a video on there. Right, so that's just that part of the process. And this is kind of what it looks like. So the existing concrete on the left, in the middle is the flush grind, and then on the right is with the second pass with the grooving to form the next generation surface. So, and that's just the installed and just demonstrating the groove width. So we got around about a 16 mil wide gap between grooves in that, and they're just under 5 mil deep. And this is a run along the site. So the video starts on an existing piece of concrete, and then it goes over a bridge deck, and it goes straight into the next generation. So a bit like the sound will come over nice and clear. So this is existing. And that's the bridge deck. And this is the next gen. And that's going back over to an untreated section. So it's quite noticeable, the noise difference. I mean, I drove over it myself, and when you're in the car, you know there's something different, but you can't actually see that treatment is there going at motorway speeds. It's very difficult to see. What have we done so far? We did all the pre-installation testing, so we've got some extensive monitoring program, which we're looking at skid resistance, 3D texture. So we've got scrim, grip tester, pavement friction tester, get high speed. And for noise, we're looking at CPX and also statistical pass-by and also in-car monitoring. We're also doing visual surveys at regular intervals on both of the M1 sites. All right, so that's skid resistance before and after installation. The dark blue line is before and the light blue line is afterwards. So you can see that's much improved. And these are the noise measurements. Significant reduction in noise level in terms of the statistical pass-by roadside. It was roughly 8 decibels and the CPX was about 5. Interesting to say how that carries on with time. But you can see, just looking at the graphic, there's a sharp drop in the levels of noise. And also post-treatment statistical bypass is it's equivalent to a very quiet surfacing. So that's kind of all we need to know from that, which is because a lot of the work we're doing is to look at the strategy for concrete roads for Connect Plus for the DBFO concession. And this is the skid resistance testing. So the dark lines on this graphic are pre-treatment, and then we've got lane 1 and lane 2 done separately. So the graph on life on the left-hand side of the screen is the peak friction, and the one on the other side is lot wheel friction. So the shaded area is kind of acceptable levels or typical levels for these types of materials, from our experience. So that was all good positive stuff. And then there's a little bit on carbon footprint assessment as well. So primary data collected, monitoring transport, fuel and plant for the next generation, sourcing of grinding blades and waste factored into the calculation, and a carbon footprint assessed using the aspect tool. And industry emissions. So that's just cradle to lathe calculations. We don't have enough data to do a whole life analysis at this stage. But basically, is the carbon footprint of basically reduced by 30%. Because on the basis it would have saved 550 tonne of asphalt. So, and savings in bitumen and primary high PSV aggregates. Conclusions, right. So for both of these, LDG and next generation, they're effective techniques in joining, restoring surface characteristics. We've got a specification for LDG. I don't think the next generation is really that significantly different apart from the actual process. First successful UK next generation installed, achieved in accordance with the specification. Extensive research and engagement undertaken prior to that network installation. I think we probably need to carry that on. I think we've got a lot more we can learn from other things going on. And we've got an extensive monitoring plan in place to see how the noise, skid resistance, texture, ride quality, etc. Changes in time.